You train a model, it sees two features that are almost clones. L1 kills one instantly. L2 keeps both, just whispers them. Here's the picture to keep in your head. You're packing a suitcase and the airline charges a weird fee. Every kilo costs you. Under L1, you pay $1 per kilo, a straight line. So you only pack an item if its usefulness is worth more than $1 a kilo. Everything else stays home. Under L2, you pay $1 per kilo squared. That means heavy items become absurdly expensive, but a tiny trinket is practically free. So you take everything, yet somehow every single thing ends up tiny. Now map that. The items are your model's features, say, number of bedrooms, square footage, the color of the front door. The weights on those features are how many kilos each contributes. The usefulness is how much a feature reduces your training error. And the airline fee? That's the regularization penalty, added right onto your loss. So the model's whole job is to minimize the total cost of the trip, training error plus penalty. The whole difference is in the shape of that penalty. L1 is the absolute value, a sharp V right at 0, it has a kink, a corner. L2 is the squared value, a smooth parabola, perfectly flat at the bottom. So when the model tries to shave pennies off the total cost, L1's corner acts like a chisel. If the error reduction isn't high enough to power past the point, the weight gets chipped down to exactly 0. L2's soft slope, on the other hand, just nudges weights gently downward. It never gives a strong enough reason to hit absolute 0. Unless the feature is genuinely useless and the error gradient is already 0, and that almost never happens. That's why after L1, your model's weight list looks like Swiss cheese full of zeros. Only the features that truly pull their weight survive. After L2, every feature still chips in, but all the voices are turned down, nobody's screaming. So L1 is a feature selector. It automatically keeps the important variables and drops the noise. L2 is a shrinkage tool. It fights over fitting by keeping all weights small, but it never lets them vanish. And here's the real click. Imagine you set a hard budget on the total weight, say, the sum of absolute values can't exceed a limit. That feasible region is a diamond. For L2, the constraint is on the sum of squares, a circle. Now, the contours of your training error are like ripples spreading from the center. The regular is ED solution is exactly where the smallest error ripple just touches the boundary. With the diamond, the first kiss happens at a sharp corner, right on an axis. It kills a weight. With the circle, the touch is smooth, usually not on an axis, so no weight gets zeroed. The geometry decides everything. So next time you're packing, remember, if the fee is linear, you leave the heavy junk at home. That's L1, also called lasso. If the fee is quadratic, you bring everything but mini at Yuri said, that's L2 or rich. In machine learning, L1 gives you a sparse, interpret-able model that ignores irrelevant features. L2 gives you a dense, stable model that tames every weight. Same penalty idea, utterly different result because of a corner versus a curve.